Okay, let's dive right into this. Welcome to today's Explainer, where we're tackling what is arguably one of the most fascinating and, let's be honest, profoundly misunderstood topics of our time: artificial intelligence. We are going to totally strip away the sci-fi myths, the Hollywood sensationalism, and look strictly at the facts. We really want to demystify exactly what AI is and, honestly, more importantly, what it isn't. And here is the absolute foundational truth we're going to anchor onto today. AI is not human. It is made by humans to serve humans. I know, right? Despite all those blockbuster movies featuring sentient, plotting robots, this is the one powerful reality we need to remember. AI is an incredibly sophisticated tool, but at the end of the day, it is just that, a tool. Now, what's really interesting about how we're breaking this down today is the structure. We'll start by looking at AI as a human-made discovery. Then we'll get into exactly how it's made, how it actually works under the hood, and finally, its real-world impact, first serving in healthcare and then expanding out across global research and industry. Section 1. A human-made discovery. Pop culture absolutely loves to depict AI as this glowing, ethereal, floating, sentient mind. But the physical reality? It's kind of ironic. It sits squarely inside human laboratories. It is totally surrounded by human scientists, physical microscopes, and robotic arms. It operates completely within the boundaries of our design, literally just doing the heavy lifting that we built it for. Moving right along to Section 2, how AI is made. So, creating AI is actually a highly structured three-step process, and it is driven entirely by human engineering. First up, data collection and training. That's us feeding the system massive, just unprecedented amounts of data. Second, algorithms. These are the advanced mathematical codes and models literally written by human programmers. And third, neural networks, which is the complex digital architecture we build to actually process all that data at scale. And hey, real quick, when we talk about neural networks, we definitely aren't talking about a synthetic biological brain. We are talking about billions of connected digital nodes designed to process advanced code. Sure, it's loosely inspired by biological pathways, but it remains pure, unadulterated mathematical architecture, built by hand to process information millions of times faster than we ever could manually. Which brings us to Section 3, how AI actually works. So the crucial point here is that in action, AI really boils down to three core functions: machine learning, where the system adapts based on the data it processes; pattern recognition, which is arguably its absolute greatest superpower, combing through millions of data points to identify minute trends that are totally invisible to the human eye; and finally, decision-making, generating solutions based on those trends. But remember, its quote-unquote learning is entirely mathematical pattern matching based on human-provided data. It's math, you guys, not magic. Let's transition to Section 4, AI serving in healthcare. And this brilliantly illustrates the massive gap between the digital sci-fi concept of AI, like a sleek robotic hand analyzing a glowing DNA strand, and the actual physical reality. The reality is super practical. It's an AI-driven robotic arm working right alongside humans in a brightly lit, totally normal laboratory, processing physical vials and just accelerating human-led research. In the medical field, AI's pattern recognition is nothing short of revolutionary. As a diagnosis aid, it analyzes scans to catch anomalies with just incredible precision. In drug discovery, it simulates complex chemical reactions like mapping protein folds, which saves literally years of trial and error. It's guiding robotic surgery with sub-millimeter accuracy and completely transforming patient care through predictive monitoring. But the biggest takeaway? It acts as an assistant, empowering our doctors rather than replacing them. Let's move to Section 5 and see how this builds across research, education, and industry. What is truly fascinating here is that the exact same underlying mechanics, that pattern recognition and machine learning we talked about, drive wildly diverse applications. In research and education, AI is mapping complex genomics and powering virtual tutors that adapt to a student's individual learning pace. Meanwhile, in industry, that very same intelligence is driving automated quality control and predictive maintenance. That means allowing factories to fix machines before they even break, which saves millions in global supply chain disruptions. It's everywhere. So, as we bring this explainer full circle, let's return to our starting premise, just to make it crystal clear. AI is not human. It is a human tool. For all its staggering complexity, all that mind-blowing processing power, it possesses absolutely no consciousness, it has no intent of its own. Human ingenuity remains firmly, undeniably in the driver's seat. Which brings us to our final thought for today. If this tool, built with our data and our algorithms, can already revolutionize our laboratories, accelerate medical breakthroughs, and completely optimize global supply chains, what will we teach it to solve next? The future of AI really isn't about what the machine will decide to do. It's about what we, as its creators, will direct it to achieve. Thanks so much for joining me on this explainer. Stay curious, and I'll see you next time.